Hello everyone, let us now discuss today's LeetCode POTD problem, minimum time to repair cars. So here we are given with ranks, that means ith rank represent 0 at 0 represent the driver 0 is having the rank of 4, and if a driver is having a rank of something like 4, the time to repair a car or one car will be 1 into 1 into the rank. But what if he repairs two cars? Then the time to repair two cars will be the rank into 2 into 2. So the time to repair n cars or will be ranks of I into n square, where n is the number of cars he will repair. So this is the time to repair by each mechanic. Now here it is 1, 2 and 3. Now total cars are 10. I need the minimum time which is took by all the mechanics, and I need the minimum time to repair all the cars. Now it is said that they can work simultaneously. That means this worker can work for two cars, and this worker can work for two cars, and this for two cars, and this for four cars simultaneously. So if he is working, and he can also work in the same time, if he is taking like 4 into 2 8 into 2 16 and 2 into 2 into 2 8, then in 8 minutes he completed his work, and in 16 minutes he completed his work of repairing two cars. Then the maximum will be 16. So they both started at 0 and he completed earlier than this person. And I need the max or total number of minutes took to repair all the cars. That means in 16 minutes he repaired two cars. So let us take this example and solve it. So first thing, this mechanic which is having rank 4, and the second mechanic 2, and third mechanic 3, and then 1. He repairs two cars. I will tell you how you can approach this solution in just few seconds. 4 into 2 into 2. He also repairs two cars, 2 into 2. He also repairs two cars, 2 into 2. And then he repairs like 4 cars. So 4 into 2 into 2 is 4 into 2, 8 into 2, 16. 2 into 2 into 2 is 8. 3 into 2, 6 into 2, 12. 4 into 4 into 1 is 16. So that means he repairs in 16 minutes, he repairs in 8 minutes, he repairs in 12 minutes, he repairs in 16 minutes, and the total cars these mechanics have repaired is 10. If you doubt, check it. 2 plus 2 4 plus 2 6 plus 4 10. So 16 is the minutes that required to repair all the 10 cars given in the question. Now, how we can approach this question, right? So the first thing which comes to our mind is, so at least I can take only 1 minute to repair all the cars. And what is the maximum? That will be 4 into the number of cars will be 10. So what I assuming is only this person is repairing, or in the worst case this person repairs all cars, 10 cars, and there will be no other mechanics working for another cars. So 4 into 10 into 10 will give me 400. So these are the maximum minutes. These are the maximum minutes. Instead, let me call it, wait a second. Let me call it as high value, and let me call this as lower value. Now, what I think is going through this in taking like 1 to 2, 3, 4, and so on will take much time than expected, which will return a time limit exceeded error. Now, how I can take like 2, 3, and 4, and then something like imagine I got at 16. So instead of going through one by one, what if I go in a binary search way? So I'll get 200, right? At first, I'll get the mid value as 200, and absolutely I'll get more than 10 cars that can be repaired. I will tell you how you can count by taking these minutes. This is the maximum minutes. If I call it as this is the maximum minutes. If you see here 16 is the maximum minutes. Now 200 will be the maximum minutes and this is the mid value. So I am treating this as the maximum minute. Every time you get a binary search, so we iterate on our answers. We iterate on our answers. Remember this carefully that we iterate on our answers and we just need to know when to go left and when to go right. So when to go left, that means this value is greater than expected. When to go right, this value is lesser than expected, lesser than our answer. Now, as I said, answer we will be iterating on answer every time on when we are using binary search. Now, 200 is the first case. I'll start by 100, right? By taking 100. So 100 will also be exceeding. Let me check how it will be exceeding. So the ranks which are given is 4, 2, 3, and 1, and the total number of cars are 10, right? So the maximum minutes I have given is 100. They said to me that 4 into 2 into 2 is the minutes. So 4 into something like, let me take it as n into n should be lesser than or is equal to 100. This is the quite interesting approach or intuition that n into n is the number of cars. N is the number of cars that can be repaired. And 4 into n, the rank should not be exceeding 100. But why? Because here I am taking 16. This is my answer and all the other values are lesser than 16. If you see, observe carefully that these are lesser than all the values. That means 16 is the number of minutes required to prepare all the cars. That's it. Now 4 into n is lesser than or is equal to 100. I need the count of cars that can be repaired by taking 100 as the maximum minutes. Now, what I need to do now? If I get greater than cars, that is 10, then I need to go left, right? So that means I am taking more than expected value. So if I get lesser than 10 value, then I need to go right. That means I am taking lesser than expected value. Greater than or is equal to, then I need to go left. If it is lesser than 10, then I need to go right. Now 4 into n. So how I can get all the count? Let me say you that n square is lesser than or is equal to 100 by 4 will give me 25, and the number of cars this person, like, which is having a rank of 4, that can be repaired are 5. The number of cars repaired by this rank, this mechanic having rank 4 is 5. Now, this is the first thing I did. So, let me remove this here. Now, I have the next thing 2. 2 into n into n. 2 into n is lesser than or is equal to 100. So n into n square is lesser than or is equal to 50. Let me open calculator. So 50 square root will give me 7. So n is lesser than or is equal to 7. So we can So this mechanic repairs 7 cars. Now, what is the time now? Here I am taking 7 plus 5, 12, which is greater than 10. As I said, if it is greater than or is equal to 10, or the number of cars, go to left. If I go left, that means I am setting my high value to the mid. Then I'll get 50. So if I get 50 as the mid value, I'll do this again. So when I take 100 as the maximum minutes, now I am taking 50. Now I am taking 50. Now I am taking 50. So here it is, right? So 4, 4 into n into n. 4 into n into n is lesser than or is equal to 50. So n square is lesser than or is equal to 50 by 4. Let me open the calculator. 50 divided by 4 is equal to something like this. 12.5 and square root will give me 3. So n is lesser than or is equal to 3. So here I got 3, right? Let me do the same for 2. Instead, how I can write it simply? Here n square is less than or is equal to 50 is the maximum minutes by 4. So n square is lesser than or is equal to 50 by 2. 50 by 2. 50 by 2 will give me 25 and n should be lesser than or is equal to 5. Here I got 5. Now this is the second thing. Here now I'll go to 3. So n square is lesser than or is equal to 50 by 3. I can also write it as, let me show it again. 50 divided by 3 is 16, and if I take the square root of 16, it will be 4. So n is lesser than or is equal to 4. But if you see, if I add all these values, 3 plus 5 is 8 plus 4 is 12, which is exceeding the number of cars that we have to repair. So I'll take lesser than even this value. If I take lesser than this value, it will be 25. So instead of iterating all this, let me go directly to the answer 16 and let me find out how I can get these count as 10. No, the maximum minutes is 16. Instead of taking n square all this, n will be lesser than or is equal to square root of 16 by 4. So square root of 16 by 4 will give me n is lesser than or is equal to 2. So here it is 2. Now if I place the same, instead I am taking 2 here. Instead I am taking 2. Let me check out how I can get this 2. 16 by 2 is 8 and it will be, if I take the floor value, it will be 2 again. So here also it is 2. Now here also it is 2. Now I am taking 3 as my value. Here I am taking 3 as my value. So 3 5s are 15 and square root of 5 will be also 2. Now it is 2. Till now the count is not greater than 10. Yes. And the last thing here it is 1. If I take 1, 1 by 16 is 16 and square root of 16 is 4. So if I add 4 here, I will get exactly 10. And the another values which are lesser than 16, which is 15 and 14, and even if I take binary search, 8 will not give me the perfect answer. It will be lesser than the number of cars required. Now what will be my algorithm? So whenever we are using a binary search, the first thing I need to know is low and high. And the second thing, I need to know when to go left and when to go right. So the first thing is low. Low will be initialized to 1 and my high value is initialized to here 1 long it is took like 1 long and also the number of cars in a worst case cars into cars as I said into ranks of 0. Now while low is lesser than high, while low is lesser than high, I'll take mid. Mid will be my maximum value, maximum minutes. Now, as I took mid, total cars repaired, total cars repaired are initialized to 0 initially. Now, for rank in ranks, for rank in ranks, I need to do something. As I said, total cars repaired plus is equal to total cars repaired plus is equal to the number of minutes, total number of minutes. As I said, mid is the maximum value, mid by here if you see, I am taking the mid value by rank and square root of it, square root of it. So square root of mid by rank should be added to total cars repaired. Now if total cars repaired is lesser than the number of cars given to us, if it is lesser, then I need to go right. Instead, I'll write something like greater than or is equal to cars, then I need to go left. That means I am setting my high to mid. If it is lesser than cars, else. Here it is if and here it is else. Go right. Go right. Right. So low is set to mid plus 1. Low is set to mid plus 1. At last we'll be returning our low value. So this is how you solve this problem. Let me quickly explain you the code. Low is initialized to 1 and high is initialized to cars into ranks of 0. While low is less than high, mid is low plus high minus low by 2. Total cars repaired, as I said in algorithm, TCR is equal to 0. For every rank in ranks, total cars repaired plus is equal to square root of 1.0 into mid by ranks of I. This is done because we will get something like in floor value. Now, total cars repaired is greater than or is equal to cars, then high is equal to mid. As I said, is greater than or is equal to 0, high is equal to mid, and else low is equal to mid plus 1, and it is low. It is a simple question. If you know something like binary search and cut here. So if you like this video, do share it to your friends and do subscribe to my channel. Thank you.